This lesson is to derive a formula for the cosine of the difference of two angles. And so the beginning of this is very geometric, and the end of it is very algebraic. So I'm going to try to do the geometry on this page and the algebra on the next couple of pages. But what I've got started is the top half of a unit circle and an angle alpha drawn with its terminal side in the second quadrant. So it's works for any kind of an angle, but I've started there just to make things big enough to see. So because the terminal side is landing on this point on the unit circle, I know that the coordinates, the x-coordinate is the cosine of alpha, and the y-coordinate is the sine of alpha. So I've just labeled that ordered pair with the values of x and y. What I'm going to do is I'm going to draw another angle beta. And so, I don't know, maybe beta goes to here. And so, let me make that beta looking a little bit better. Beta goes to there. So just like the ordered pair on the unit circle on the terminal side of alpha is cosine alpha, sine alpha, the ordered pair right here, the x-coordinate is cosine of beta, comma, sine of beta. Nothing new here. So what I'm going to do is look at the angle in here. And so that angle right there that I've drawn in red, I contend is the entire angle alpha minus beta. Because let me just call that angle x for a second. And I can write over here and I can say, okay, well, beta plus that extra x is going to end up being the entire way alpha that I've got. You know, this plus this gets all the way to alpha. So I'm going to use that and say, well, okay, subtract beta from both sides, and this x is alpha minus beta. Okay, great. So let me not call it x anymore. Let me call it alpha minus beta. So what I'm going to attempt to do, and I'm running out of space on this page, so I'm going to do it on the other page and flip back and forth. I apologize for how confusing that might look. But what I'm going to do is I'm going to redraw alpha minus beta in standard position. It's a amount of angle, but I'm going to pull this orange side right here over to the x-axis, and I'm going to pull this black terminal side over here up alpha minus beta, that distance of angle up above. And so here on the other page, I've got my half circle, I've got 1, 0, and I'm going to put that, again, I'm going to put that orange ray on the positive x-axis, and then the terminal side, this guy over here, I'm going to put over here. And so it's the same alpha minus beta, but now it's in standard position. And so what that does is that allows me to write the coordinates of this point up here as cosine of alpha minus beta, comma sine of alpha minus beta. That's helpful, because what I'm going to do, the algebra part, what I'm going to do is I'm going to say, well, this triangle right up here is exactly the same triangle as this one over here. It's not a right triangle, there's nothing special about it, but what it is that this is the radius of the circle, this guy is the radius of the circle, this is some chord going between that point, and the angle alpha minus beta is the same as it is over here. It's alpha minus beta. So really those triangles are the same, with two sides. It's an isosceles triangle. Its two sides have radius 1, and then that one length has to be the same. Since this angle is the same, that length has to be the same. So what I'm going to do is get a expression for that length. But to do that, I'm going to need to remind myself of the distance formula. So I'm going to start the next video. This is already over 5 minutes, so I'm going to actually start the next video with those two triangles.